All right, welcome to day 2 of the Advent of Code series. So in this problem, we're going to be doing quite a bit of math and string manipulation. So what we have going on here is that the submarine that we were in on day 1 takes a series of commands forward, down, and up. So forward increases the horizontal position by units, x units. Down increases the depth by x units, and up decreases the depth by x units. So we can go down and up. These affect our depth, and they have an opposite result of what you might expect. So down actually increases the depth, up decreases the depth. So here's an example of what it looks like. Our input, and according to this input, forward adds 5, down adds 5, forward adds 8 to bring it to 13. Up decreases the depth by 3, so it changes 5 to 2. Down adds 8, so it changes to 10. And then forward 2 takes 8, 13 to 15. So after following these instructions, you'd have a horizontal position of 15 and a depth of 10. So multiplying these produces 150. So it says, what do you get if you multiply your final horizontal position by your final depth? So let's go over to code and start working on this. All right, so here we are in VS Code, and as you can see, I've already created our puzzle variable. Let's go ahead and load that up. So from here, what we need to do is just really quick, let's just take a look at the first couple entries for our puzzle input. Let's just say 0 through 3 to look at the first 4. All right, so we have forward 3, down 9, forward 5, and up 1. So if you guys remember from the page that I just had up, forward changes the horizontal position forward, down increases our depth, and up decreases our depth. So we're going to be subtracting with the up keyword and moving down, increasing the number with our down keyword. So with this puzzle, we can do a couple of things. So as I mentioned, we're going to look at some string manipulation because we have to break up the direction with the number of units that we need to move then. So let's just start with a simple for each. I'll just go ahead and dump in the snippet for this just so you guys can see that. I'm going to change these keywords a little bit. So let's just say for each direction in puzzle, so firstly, we're going to need to split the items. So let's go ahead and create those splits. So let's say that the, I guess let's change direction to line. So each direction that we move is going to be line split. We're going to split at the space because there's a space between the direction and the number. And let's say that that is 0 because this will give us the first thing in the array that it returns is 0, so the word. And then let's say the units is going to be line split space again and 1. So that'll give us the number of units to move. So from here, we just need to then look at another command or statement that we've learned, and that is the switch statement. So we're going to write switch. Let's go ahead and insert it. So we're going to be switching based on the direction on what we need to do. So there we have the direction, and let's go ahead and delete these because we're not going to have a default, and I want you guys to see this from scratch. So if the direction is forward, then we know that we need to change the, oh, whoops, I did not establish our initial array. So let's just say that we have our x position and our y position, which are both going to start at 0. We're going to initialize both to 0 because we're wherever we are, we're only counting from where we are to where we end up, not anything else. So our position is going to be 0, and this is just declaring x and y to both be 0, which I will show you here. X, y, so there we go. So forward, we're going to change x, we're going to increment it plus equals by the units. And if the keyword is down, then we are going to increment y by plus equal units. And up, we're going to subtract from the y, whatever units we have there. So, and then at the end, after we have all of this, we need to multiply our horizontal position by our depth. So we're going to just say that our final is x times y, and then let's just output that so we get the answer. So if I run this, I can see here that we have our final answer. So if I walk through this again, let me just take a look at this. So let's just look at the first entry and see what happens. So let me initialize all these back to 0. So our first position is going to be a forward 3. So all this should do is changing our x position by 3. So let's run this. Let's take a look at x. X is 3. Y should still be 0. Perfect. So let's look at what the next step is. Whoops. Down 9. So that's going to add 9 to y. So let's add 1 to this and then take a look at it as well. So our y is 9 and our x is 3 still. So if I multiply these together for the final, we would get 27. So we can see that it works correctly using the first two numbers in the set. So we can assume that our math is correct. Obviously, I'd like an up to test if we were doing this on a very large scale set of data. I think there's about 2,000 entries in this puzzle. So let's just check. There's only 1,000. So it's not that large. We probably could just eyeball this and kind of come up to what our answer should be approximate, just looking at the numbers. You know, the math overall, when we run all of this, is a fairly large number. But you can imagine that you can just add all the forward units together, and that this has to be a multiple of that. So, and we can do that by just saying puzzle and remember the aliases. I want to start getting you guys to use aliases in your shorthand code. And so we're just checking something so we can just use the alias. So where object is the question mark, and we want to just check where each line is like forward. And from here, we want to measure object and the sum. Whoops, what did I do wrong? Oh, I need to split it. And that is my fault. But again, these are errors that you guys will see. So this is good to, so what we're going to do is stop them. We're going to go back to this pipeline. We're going to say for each, which is the percent sign. And we want to go ahead and do this. And we're going to split. And we're going to split at the space again. And from there, we're going to actually just select the number 1, and then we're going to measure object here, and 1957. So if we do final divided by 1957, we should get a perfectly even number, 955. So there we are. We didn't have any decimals, we didn't have any weird numbers. So we can see that it is a whole number, so at least we're close. Just guessing quickly, just looking at this. So that's part one. So bear with me a moment while I wipe all this and come right back with the second part of the video. Alright, here we have part two. So it says, based on your calculations, the planned course doesn't seem to make any sense. You find the submarine manual and discover that the process is actually slightly more complicated. So in addition to the horizontal position and depth, you also need to track a third value, aim, which also starts at 0. The commands also mean something entirely different than you first thought. So down increases your aim by X units, up decreases your aim by X units, forward does two things. So forward increases our horizontal position, which is what we thought originally, and it also increases your depth by your aim multiplied by the current number of units that forward states. So again, note that since you're on a submarine, down and up do the opposite of what you might expect. Down means aiming in the positive direction. So down is up in number, up is down in number. So here we go again. You can kind of follow this math pretty quickly, just like before. Forward adds 2 to your horizontal position, bringing it to a total of 15. But our current aim is a value of 10. So because this is 2, we multiply 2 by our aim, which is 10. We get 20, and then we multiply, and that brings us to a total of 60, adding it to the previous number of 40. So now we need to multiply our final horizontal position by our final depth after all of this math. So remember, forward does two things. Forward increases our depth now by our aim multiplied by the current number of units in the forward direction. So it increases our horizontal position and our depth by aim multiplied by X. And then up and down do the same thing as they did before, but they're talking about our aim. So when we're doing this, we have three variables to consider. Let's call forward our horizontal position again, being our x-axis. We are still going to call our depth our y, because it is our y-axis. And let's call the aim our z-axis, because it is a third variable and controls actually what our depth is going to look like. So let's bounce back over to VS Code. Alright, now let's take a look at part 2 in code. So as I mentioned, we have three variables. We have x, we have y, and we have z. Let's initialize all of those to 0. So that's y, x, and z, all are at 0. So now we can get started. So a lot of this is going to look very similar to what we did before. So I'm going to actually change the variable names just so we can clearly see that I'm doing this all from scratch. So we're going to say is for each line in puzzle, again, because puzzle is still the same, and we're talking about each line entry in the puzzle. And we are going to say that we can do this a different way than I did before. So let's do change, and we are just going to say equals line split like we did before, except this time I'm only using one variable called change, and we're just going to say that create two new variables based on that. So we can say that our variable for our direction is going to be called change1, and our units, we can just call it n like we've done in previous videos for number, and just change 1. This is actually change 0, so I apologize. And we're going to do another switch statement. So we're going to switch on var this time. And first we have forward, which does two things. Remember, it adds the number of units to our horizontal position. So let's say x plus equals n. And it also does y plus equals our aim times the current number of units. So aim times n. Okay, and then we have our up. Let me tab this over just so it's all lined up. Okay. And our up is actually going to subtract, so z minus equal n. And our down, which is z aim plus equals n. So up and down, subtract and add to z, which is our aim. And then our forward changes our horizontal position, always adding to it. And our depth increases always by our aim multiplied by the current number of units. So just like before, let's just call this f for final equals x times y, our final positions are horizontal and depth, and we should be able to run this. And let's check this, f, and let me take a look really quick at the answer that I gave. That is correct. So we are in good shape. So we know this works perfectly fine. So for a switch statement, this is a good chance to show you that you can have multi-line statements depending on what your condition is. You don't have to have a single line condition like this. You can have, a single line statement after the condition, script block. You can have the script block be as many lines as you want. Just remember to close it and finalize it based on what the condition is. In this case, our conditions are only what var is, and is it forward, up, or down. We don't have to evaluate to anything like we can say like this, like, oops, f for forward, and we can wrap that like this and get the same result. However, we know that the word is always going to be forward, up, and down. They're very unique, so there's no reason to do that. We can just say forward. So that is all. That is day 2 wrapped up pretty quickly. So stand by. I will start working on day 3 and have that video up tomorrow.